In this video, we'll be looking with proofs involving right triangles. As a quick review, a right triangle, of course, has a right angle, two legs. The two legs are the sides that make the right angle when they join together, and then a hypotenuse, which is always the side that is opposite the right angle. So no matter how we draw a right triangle, we can always find the hypotenuse by seeing what side is opposite that right angle. Alright, so the definition of a right triangle is a triangle with one right angle. What you need to know for proofs especially is if triangle has right angle, then it's a right triangle. That's what you use as your reasoning in the proof. Alright, so the hypotenuse leg theorem is our last different form of congruence we learned for triangles. This states if the hypotenuse and a leg of one right triangle are congruent to the hypotenuse and leg of another right triangle, then the triangles are congruent. So this only works for right triangles. So notice, angle B and angle E are 90 degrees, so that makes each of these triangles a right triangle. And you have a leg congruent to a leg, hypotenuse to a hypotenuse. So triangle ABC is congruent to triangle DEF by HL. If we didn't know HL, we'd look at this and we'd see SSA, and of course we know SSA does not work. But because it's a right triangle, we can use a new theorem called HL hypotenuse leg. What you want to be careful here in hypotenuse leg is you're trying to show three things proving hypotenuse leg. One, that you have a leg congruent to another leg, so in this case it would be AB to AB, AB to DE. You have a hypotenuse congruent to another hypotenuse, so in this case AC is congruent to DF. And third, you're trying to show that both triangles are right triangles. You're not trying to show that the angles are congruent because that would be SSA. You're just trying to say in the proof that triangle ABC is a right triangle and triangle DEF is a right triangle. So what additional information do I need in this problem to prove that the triangles are congruent by HL? Well, I have a hypotenuse to hypotenuse, leg to leg. So I need to know that angle T and angle Q are both right angles because that tells me that this triangle, BLT, would be a right triangle and triangle RKQ would also be a right triangle. In this problem, what additional information do you need to prove the triangles are congruent by HL? Well, given information is that they're right triangles and that their hypotenuse are congruent to each other. So all you need to know is that either XV is congruent to TV, that would be a leg to a leg, or that XR is congruent to TR, that would also be another leg. For what values of X and Y are the triangles congruent by HL? You might want to pause and try to see if you can figure out how to solve this system. Alright, if they're going to be congruent by HL, that means that this side right here has to be congruent to this side. So that means that X has to equal Y plus 1. Also means that this hypotenuse has to be congruent to this hypotenuse. So X plus 3 has to equal 3Y. Well, you have X equaling Y plus 1, so I can plug Y plus 1 in for X. So Y plus 1 is X, then plus 3 equals 3Y. Y plus 4 equals 3Y. Subtract the Y, 4 equals 2Y, so Y equals 2. Now we plug 2 in for Y, so X equals 2 plus 1, so X equals 3. So if X equals 3 and Y equals 2, then these two triangles will be congruent by HL. Finally, let's try two proofs. I want you to pause this proof, and I want you to try it on your own, even if you don't know what you're doing yet, to try to at least set it up and see how far into the proof you can get. Alright, let's give it a try. So, let's mark up the picture. MN, perpendicular to ON, that makes that a right angle. OP to MP makes this a right angle. NO to MP, and then finally a reflexive side. So this looks like it'd be SSA, but SSA doesn't work. So we're going to have to go with HL. Okay? So we write our givens, MN, ON, OP, MP, NO is congruent to MP, and finally our reflexive, MO to MO. Well, because these two lines are perpendicular, this line's perpendicular to ON, OP to MP, we know that angle N and angle P are right angles by definition of perpendicular lines. And if those are right angles, we know that triangle MNO and triangle OPM are right triangles, because if triangle has right angle, then it's a right triangle. You might be tempted in this box to say angle N is congruent to angle P because that's what we did with all of our other proofs. However, if we want to show HL, we have to prove that those triangles are right triangles. So you have to have the step of proving the triangles are right. Once we've proven the triangles are right triangle, that's one of our 3 steps for HL. We join it with a leg, NO to MP, and the hypotenuse, the reflexive side, to say triangle NOM is congruent to triangle PMO by hypotenuse leg. And then finally, we know that NM is congruent to OP by corresponding parts if congruent triangles are congruent. Let's try one more proof. So pause the video and try this one out. All right, let's mark up the picture. AB is perpendicular to BC, DC to BC, perpendicular. AC is congruent to DB. Now I'm not going to mark that because it's going to be kind of confusing looking because they're overlapping. But know that these long sides are congruent to each other. And finally, we know that BC is reflexive on itself. So once again, this would look like side-side angle, but that doesn't work. So when we see a right triangle, we know that we can use hypotenuse leg. So let's see how you did. You write your givens, the perpendicular parts, the AC to DB, and our reflexive side. We know that angle ABC and angle DCB are right angles by definition of perpendicular. And if we're trying to use HL, we don't want to say they're congruent, but we want to say that they're right triangles. So triangle ABC and triangle DCB are right triangles because if right angle, so sorry, before I said if triangle has right angle, then right triangle. Once we've proven the right triangles, we join it with our hypotenuse and our leg to say triangle ABC is congruent to triangle DC, that's a C, B by HL. Now, if those 2 triangles are congruent, if you look at triangle ABC right here, you have this angle inside triangle ABC. If you look at triangle BDC, you have this angle. By corresponding parts, angle ACB will be congruent to angle DBC. If those 2 angles are congruent, then you know that you have 2 base angles are congruent. So EB has to be congruent to EC. Because if base angle is congruent, then legs are congruent. And finally, if the legs are congruent, then the triangle is isosceles. So triangle BEC is isosceles. So make sure you give those proofs a good practice on the homework. Thank you for